Good morning. I hope that you all are staying warm and safe. I apologize to any of you that showed up at class at 10 o'clock this morning. Hopefully my announcement reached most of you or all of you before 10 o'clock, but there's always a little delay between when I post it and Moodle, and it actually shows up in your email. So hopefully you all checked your Moodle account. In any case, I'm going to go ahead and go over the notes that I was going to go over in class today, wrap up the notes from from Tuesday, and then go over some notes that I was going to talk about today. Additionally, I will post your lab that we were going to do in class today, and you can bring that to class with you on Tuesday. Feel free to email me if you have any questions. I'll be checking my email throughout the weekend. I guess as long as we have power. It looks like we're going to get a little bit of weather this weekend. But in any case, let's get started. This is going to be pretty informal. And I'm probably going to break it up into several short videos just so that it doesn't get too tedious. All right. So today, these were my plans to answer questions about my math lab and so forth, and to remind you all to complete the syllabus verification in Moodle. If you have any questions on section 1, 2, and 6.1, please send those to me via email, and I will postpone your due date on your homework assignment until Wednesday so that we have Tuesday to answer questions on those face-to-face as well. I'm going to wrap up section 6.1 and introduce content from 6.2 today, talk about solving algebraic equations. Your lab, again, will be in Moodle. You can print it out or just write the problems or work the problems out on notebook paper and turn that in to me on Tuesday. And then on Tuesday, we are going to move forward, but like I said, I will answer questions on this content. So, all right, so the last thing we were doing in class on Tuesday was we were starting to talk about simplifying algebraic expressions. We talked about terms. This is a variable term. Here, this is a constant term here, and sorry, my computer's a little finicky here. So, this being our variable term, this is a constant term, this is a constant term. When we have a number outside of the parentheses, if you cannot combine the like terms that are in parentheses, then you can distribute. And this, I think, is where we were wrapping things up in class on Tuesday. So let's start here. When you simplify an algebraic expression, we want to combine all like terms, perform all operations, and your algebraic expression is simplified when there are no more like terms and no more operations to be completed. So when I distribute here, 4 times 3, we multiply the constant times the coefficient 3 there, and so that's going to give me a 12x. Please forgive me, my tablet's not working with this program for some reason. And then I distribute this here, it's going to be a minus 16. And then we tack that minus 7 on at the end. So remembering our order of operations, we multiply and then we add or subtract. So here, let me try my tablet again. So here, I have a 12x minus 16 minus 7. These are both constant terms, so I can combine those, giving me a minus 23. And if you are struggling with operations with integers, signed numbers, I will be glad to give you some more review problems or so forth. Or you know, at this point you can always use your calculator. So negative 16 minus 7 will indeed give you a minus 23. So there we have 12x minus 23. We cannot combine those any further. They are not like terms. And remember, this is not an equation. So we're not solving it, we're merely simplifying it. Okay, so let's work on the second problem here. Let's see, I'm going to go ahead and type this. See, this is going to be 4x squared minus 3x plus 2 and 6x squared plus 2. Just writing it over here so it's easier. Okay, so the first thing we want to do, we want to look and see if we can combine any like terms in these parentheses, see if there's anything we can do to simplify what's in the parentheses. This is a 4x squared, and this is a 3x, so they cannot be combined, a 6x squared, and a 2, so they cannot be combined. So our order of operations tell us to complete what's inside any operation, or excuse me, any grouping symbols. And so we cannot combine those, so we're done. The next thing we do is look at exponents. There are exponents, but I cannot do anything with that x squared, so I can't take that any further. And then we want to multiply. So here I'm going to distribute. And when I do that, that's going to give me 20x squared minus 15x. Paying attention to your sign. And then here I'm going to distribute. I can't add that 2 because it's being multiplied, and we want to multiply before we add. So that's going to give me 12x squared, and then 2 times 2 is 4. Nothing wrong with drawing arrows. Honestly, even if I was doing this problem by myself, I would draw the arrows real quick just to make sure I cover everything I need to do. Now we can combine like terms. I have a 20x squared and a 12x squared minus 15x and plus 4. Notice the sign that goes with it is the sign that's in front, so this minus technically is like a plus, a negative, or minus 15x, and that's a plus 4. Combining my like terms, this gives me 32x squareds. Notice if I add 20x squareds and 12x squareds, I just end up with 32x squareds. The exponent does not change. And then I have a negative 15x or minus 15x plus 4. I cannot combine like terms. I don't know what x is, so I cannot evaluate this. I don't have anything to substitute in there, and therefore it's not equal to anything either, so it's not an equation. I just use these equal to bars as I simplified. And so we're done at this point. It is simplified. Okay, looking at problem 3 here, I have 3y minus 5y plus 2. Look inside your parentheses. 5y plus 2 are unlike terms, so I cannot combine those. There's an understood 1 out here, just like I was talking about with your variable. If I have just an x, it's an understood 1 there. Same thing here. There's an understood, let me pull up a different color. There's an understood 1 right here. So really you're just distributing this negative 1, which case it changes every sign within that parenthesis. So this becomes 3y minus 5y minus 2. My like terms are 3y and 5y, so that becomes minus negative 2y minus 2. And these are unlike terms, so I can't take that any further. Alright, this I skipped on Tuesday because I wanted to get back to it. Formulas and mathematical models. A formula is an equation that uses variables to express a relationship between two or more quantities. And the process of finding these formulas to describe real-world phenomena is called mathematical modeling. We'll be talking about a little bit more about this later in the semester. For right now, we're just going to look at these formulas that have been created using mathematical modeling. All right. So in this example, this is from your textbook. It's modeling caloric needs. This bar graph shows the estimated number of calories per day needed to maintain energy balance for various gender and age groups for moderately active lifestyles. So if we look at this, here it's saying if you're between 4 and 8 years old, this is group 1, then the calories needed to maintain energy balance for moderately active lifestyles. So if you're between 4 and 8, you need about 1,500 calories for both men and women. I guess at that point it would be girls and boys. From 9 to 13, for women, you need 1,800 calories, and for men, 2,000, and so forth. So that's what this graph is telling us. For anyone 15 years or older, women need 1,800 calories to maintain energy balance for moderately active lifestyles, and men 2,300. So this is our graph, and this is a mathematical model that was created based on these data points. It describes the number of calories needed per day for women in age group X with moderately active lifestyles. According to the model, how many calories per day are needed by women between the ages of 19 and 30, inclusive with this lifestyle? So, the first thing it's asking us to do, according to the model. So this right here is our model. This right here is the graph. This is the data that's giving to us. So they created a mathematical model. A model doesn't necessarily give you the exact data points. A model gives you sort of a general idea, an estimation of what it could be so you can make predictions. So if we look at the 19 to 30 age range, notice that's group 4. So if we come back here, it's age group 4, so we're going to let x equal to 4. So x is 4. So what we're doing is we're substituting 4 into this mathematical model. Times 4 squared plus 526 times 4 plus 1030. So I'm just going to do this with my calculator. And when I do that, let's see, I'm going to get, so this is, oops. So this is negative 66 times 16 plus 526 times 4 plus 1030. So I'm just going to multiply this straight across. So negative 66 times 16. Again, your calculator knows your order of operations. So if you just type this straight in, it gives you an answer of 2078. So what this tells me, so this is calories, is that this model was created based on the data points. And a model literally does that. It just models the data that you have. It's not always going to be exactly, it's not going to give you the exact values, but it's going to give you just a general idea. And the reason we create models is so we can make predictions about values that we don't have the information for. So, but here we used it for group X or group 4. We substituted in, and it's saying that we need 2078 calories. And then it's saying, does this underestimate or overestimate the numbers shown by the graph? So if we go back to the graph here, this is saying here for women between the ages of 19 and 30, women need 2100. And you can see the model is a little bit off, but not by much. So it gives us an actual underestimate. So this is an underestimate of the actual amount of calories that are needed. Okay, hopefully that makes sense. If you have any questions, please let me know. And I'm going to stop here and then do another video with the content from section 6.2.